Hello everyone, myself Pavitra Shanbag, Department of Mathematics, AJIT, Mangaluru. In last class, we have discussed about the dual of the problem, right, in operation research. Now, let us discuss some problem based on the duality. Now, first we have to check what is given in the question, that is maximization part given or minimization part given. Now look at here one example. Prove using duality theory that the following LPP is feasible but has no optimal solution. That is minimization of z equal to x1 minus x2 plus x3. Subject to the constraints x1 minus x3 greater than or equal to 4 and x1 minus x2 plus 2x3 greater than or equal to 3 and x1 x2 x3 all are positive given, right? First we have to write it in the standard form and check whether it is in standard form or not, because for minimization we require the inequality greater than or equal to in the constraint. Similarly for maximization we require less than or equal to inequality sign in the given constraints. Okay, now first write here minimize z equal to what, x1 minus x2 plus x3 and x1 there is no x2, so plus 0 x2 it should be minus x3 greater than or equal to 4. And next inequality you have to write the same because it is in already in the standard form, that is x1 minus x2 plus 2x3 greater than or equal to 3, where x1 x2 x3 all are positive, right? Now first we have to write the primal equation or a primal LPP. After that you have to write the dual. This already we have discussed in the previous slide. Now look at here how to write the dual. Now first you have to check whether here how many constraints are available. There are only two constraints, right? Since there are two conditions or two constraints, so how many variables we have to choose? Two dual variables we have to choose. What are those? W1 and W2. Now first write the dual of this. How to write the dual of minimization? That is maximization, right? So minimize dual is maximize and instead of z we have to take z dash. How to write the dual of this? Maximize z dash equal to b into, that means b transpose into w we have to write. What is A, B, C here? A is nothing but the coefficient matrix of this constraints LHS part, that is 1, 0, minus 1, 1, minus 1, 2. And what is B? The constant part, that is 4 and 3, B. And what is C? The given minimization condition, that is coefficient of this x1, x2, x3 is C, that is 1, minus 1 and plus 1. Okay, now we have to write the dual, that is maximization of z dash equal to what? B transpose into W, subject to the constraint A transpose into W, which is less than or equal to C transpose. This concept we have already discussed in the previous slides. Now what is A transpose? Here this row wise elements we have to write it in the form of column, that is 1 1 0 minus 1 minus 1 2 into what is W? W1 into W1 and W2, which is less than or equal to C transpose. Already we have discussed C means the coefficient of x1, x2, x3 from the condition of minimization. So 1 minus 1 1. Write it in the column matrix. Now it is just like a simple matrix multiplication, row into column. So 1 W1 plus 1 W2, which is less than or equal to 1. Similarly 0 W1 minus 1 W2, which is less than or equal to minus 1, and minus W1 plus 2 W2, which is less than or equal to 1, where W1 and W2 are positive. Okay, now this we have written just a dual of the concept. Okay, that only here we have given. I have given the explanation here how to write the dual, that with the help of the condition A transpose W, which is less than or equal to C transpose, and for this maximization Z dash we have to use here B transpose into W. Now we have to impose this condition on this. will get the dual of this form, right? Now this one we have already discussed. Now to solve the dual problem, first write maximization z dash equal to 4w1 plus 3w2. Now here for less than or equal to, we have to convert it into the equality sign by using the slack variables. Now what we will get the slack variables here? W1 plus W2 plus 1s1 equal to 1. And for the second condition, what is given here? Less than or equal to negative sign is there. So we have to add the surplus variable, that is minus s2 we have to add. Now to avoid the negative sign, here we have to consider one more variable, that is artificial variable a1, right? So 0 w1 plus, here it should be minus w2 minus s2 plus a1 equal to 1, and minus w1 plus 2w2 plus s3 equal to 1. Students, look at in the this expression. Suppose if you want to take minus sign, then it should be converted in the form of plus s2 then minus a1. To avoid the confusion, here we have first multiplied with the negative sign, then only we have added the artificial variable. Especially this step is very very important. Now s1 and s2 s3, these are what? Slack and surplus variables respectively, and a1 represent what? Artificial variables. Now let us move to the big M method. This is under big M method. It is already we have done in previous class. Now first let us concentrate on this table. That is what? Here first we have to choose Cj. Cj means what? The coefficient of w1, w2, s1, s2, artificial variable, whatever we have taken, that one. Now what is CB? That is cost vector corresponding to the XB. XB is nothing but basic feasible solution, and B is nothing but base variables. Whatever we have chosen, S1, S2 and S3 and artificial variable we have chosen already, right? Now let us concentrate on the coefficient of the expression. Now look at here. How to write this? 4w1 plus 3w2 plus 0s1 plus 0s2 plus 0s3, like that, right? Now minus ma1, because we are applying the big M method. We have already discussed about big M method. I am not going to repeat that here again. Now with the help of this, we have to write CB, that is Cj, that is all the coefficient of this. That is what? Look at here. 4, 3, S1 is 0, even S2 also 0, S3 0, but for artificial variable we have to multiply minus m, right? Now write the coefficient of remaining all the expression. That is first constraint. What is given? See here, 1w1 plus 1w2 plus 1s1. So that means s2, s3, a1, everything 0 here for the first constraint. And what is this represent? This is the base variable we are writing here. That is what? First look into this part. Now 1 1 1 0 0 0. Okay, now this is xb, and here we have chosen S1, A1 and S3, right? Now write the coefficient of S1. S1 is nothing but here coefficient is 0. Next S3 coefficient also 0, but for A1 here minus m, right? Now what is given in the equality sign RHS part of the above expression? See here 1 1 1. So for all the expression we are getting 1 1 1. That only we have written in the XB part. And similarly w1, w2, w3, w1, w2, s1, s2, s3 and artificial variable we have to choose according to the given expression. It is just like a big M method only. Now look at here. First we have to find Zj. How to compute Zj? CB into XB, that is 0 into 1 plus minus M into 1 plus 0 into 1. So what we will get? 0 minus M, 0. So what is Zj value? Minus M. Similarly, what about this? 0 minus 0 plus 0. So total it is 0 only. Next again 0 into 1 minus M into 1, 0 into 2, that is minus M. Now 0 into 1, everything 0 here. Next what about this part? Here only minus M into 1, that is minus M. Here we are getting minus M into minus 1, that is plus M, and rest all you have to write like this only. After computing Zj, we have to compute Zj minus Cj. This we have already discussed in the big M method. Same method we are following here. Now Zj minus Cj. Now after computing Zj, what is Zj minus Cj? Look at here. 0 minus 4, that is minus 4. Minus M minus 3, that is minus M minus 3 only. Now 0 minus 0, 0. M minus 0, M. Minus M plus M, 0. 0 minus 0, 0. Now first check which is the least negative value here. Here we are getting minus M minus 3 is the least negative value. So we have to assume this column as pivotal column. Okay. Now we need to find pivot element. How to find the pivot element? Look into the W2 column and look into the XB part. Find minimum of the ratio of XB by W2. That is minimum XB by W2. So what we are getting? 1 by 1, that is 1 only. Here 1 by 1, again 1 only. But 1 by 2 we are getting half. So which is the least comparatively this? So 1 by 2 is the least. So what happens here? This row, this element, that is 2, acts as a pivot element. Now what happens? Since it is in the third row, this S2 vanishes and it will be replaced by W2. Be careful with this, because this is the pivot element and this is pivot column and this third row is pivotal row, because minimum ratio available here. Now what happens? This S2 we are going to remove and we are replacing that by W3. That is its value we have to consider. W2 value is 3. So this all remains same. 0 minus M, everything remains same. But here S2 replaced by 3 and this S2 replaced by W2. Okay. Now after this step what we have to do? We have to eliminate this and we have to make it one unity. How to make it unity? Just R3 implies R3 divided by 2. I have explained the row operation in the next slide. You can go through with that. After this step we have to make this as unity. Okay. So what we have to do? R3 we have to divide throughout by 2. So 1 by 2 minus 1 by 2 and 1 0 0 0 1 by 2. But what about these two? After making this one as unity, we have to make this and this value as 0. How to make it 0? R1 implies R1 minus R3 and R2 implies R2 minus R3, because we are making this as 1 already. Okay. So after applying this, what we will get? See, 1 minus half is half. Next 1 minus half is, that is 1 minus of minus 3 by 2. Next again we are getting like this the row operation. Again compute Zj. What is Zj? 0 into half minus 1 M into half plus 3 into half. So that is what we are getting here. Now similarly find each and every case Zj. Now compute Zj minus Cj and check here 5 by 2 minus M by 2 or minus M by 2 plus 5 by 2. So here what we are getting? 5 minus M whole divided by 2 we can write. Similarly here 0 0 M 0 M plus 3 by 2. Clearly we can observe all the values of Zj minus Cj are positive, so that we can stop the iteration here. See, since all Zj minus Cj are positive and an artificial variable appears in the basis at the positive level, right? So here what we are getting the artificial variable here. we are getting here positive value, right? So we can stop at this stage, that is the dual problem has no optimal basic feasible solution. Therefore, there exists no finite optimum solution to the given primal LPP. It is unbounded solution, right? Now you can refer here this for row operation purpose. If you have any doubt, you can clarify here. Okay. Thank you, dear students.